Hello, this is a presentation on stock market prediction using hidden Markov model. I will begin with some background. In this project, I'm going to predict today's closing price of a stock symbol. So when you talk about the stock market prediction, according to uh, efficient market hypothesis, it is unpredictable because of random walk hypothesis. But I assume that in this project, I assume that there are patterns which can be predictable. There are a number of ways for stock market prediction, such as fundamental analysis, in which um, we look at companies' performance, such as price earnings ratio, and in a technical analysis, we look at only the charts rather than company's performance. Exponential moving average is one such an example. As an alternative, we can use artificial neural networks or internet-based data sources like Google Trends. So in this project, I'm going to use a hidden Markov model, which is usually studied in speech recognition or handwriting recognition or bioinformatics area. So there are a lot of ways to predict the stock market. There are time series prediction algorithms and artificial neural networks and support vector machines, Bayesian networks, Kalman filter. Usually, HMM is used to find hidden states or patterns based on observed outputs, and this is considered the simplest dynamic Bayesian network. And there are several advantages of HMM. It has strong statistical foundation, uh, random process, Markov process. It is able to handle new data robustly, and also it is computationally efficient to develop and evaluate, and is able to predict similar patterns efficiently. So there are a number of elements of HMM. There are the number of hidden states, the model, and the observation sequence and state sequence, and there are also a transition matrix, and which and also observation emission matrix, and also uh, the prior probability pi. So this is the trellis diagram that illustrates HMM using the graphical model. There are three basic problems for HMM: learning, decoding, evaluation, uh, which are proposed by Rabiner in 1989. Learning determines the parameters of the model, and decoding determines the most probable state sequence, and evaluation computes the probability of the observation sequence. So given the opening price, how to predict the closing price using HMM? First, I define the observation um, sequence, which is causing um, by the I define the observation output by the stock price change, which is closing price minus opening price. So once we got the predicted change, we add it to the opening price. And in this particular case, we have five hidden states. And to improve prediction accuracy, we use the mixture of four Gaussian distributions. So here we have steps for prediction. We first initialize the state and construct a model using boundary algorithm. And then we found the most probable current state using zero algorithm and the most probable price change finally, we add the predicted change to the opening price to obtain the predicted closing price. So here is an example of prediction algorithm. So the current state is 1 in gray, and the next state in blue is 1, 2, 3, 4, or 5. So from the current state to the next state, there are 5 possible transitions, A11 through 1, A1 through 5. Then the next state emits the observation with a mixture of 4 Gaussians. Now we marginalize all the possible cases, which are 5 by 4, 20 Gaussians, so that we can predict the next observation in yellow. So this program is written in R. I use 2 packages, RHMM and QuantMod. They are very easy to use, and I recommend the package if you want to do something with stocks. So I use stock analysis of 6 companies, and here is the table for data set period. So, but some simple data set contains missing values, like an A. So I had to remove them before processing the data set. So now it's time for program demo. So I'm gonna show how to run the program. So here I have 2 files, makefile and run. Makefile is just to run the program, and run is the actual code. This is actually a bash shell code to write the R code. This part is for to specify the symbols. And here now we have only one Facebook symbol, and then we can here training period, and you can specify test period, and also these red letters are the code for R, to write R. So here this part is to run the Baum-Welch algorithm by calling the HMM fit function to construct a model, and then we run the zero buying algorithm to find the most probable state sequence. And so that process is repeated for every day, all the days in the data set. So and this part is to predict the price change. So it marginalizes all the possible cases and then adds the changes to the opening price to predict the final closing price here. And then it constructs a new model and find the new most probable state sequence. And this is pretty much done with the code. Now I'm going to run the program. All you have to do is just to type make, and you may need to wait for some time for it to finish. So once the program is done, you can see all kinds of results. So now let's look at the results. So now we have some statistics here, which I'm gonna explain later in the slides. So now you can see the results output files. So let's look at the results. This file, you can see all kinds of intermediate and output results. This file. First of all, you can see the data sets. This is the training data sets, and then this is the data sets without missing values, and this is the test set. Now, this is the model part HMS function, which is called in the program. And so you can see the model file states with a mixture of four Gaussian distribution and von Welch status, and initial probability, the transition matrix, and Gaussian mixture. And this is the nearby path, sequence path, and this is the last one. And now we can see the change, price change, and then this is the predicted closing value. And at the end of the file, you can see the statistics for performance metrics. So this is pretty much done with the code. Now let's go back to the presentation. So now let's look at the performance evaluation. So here we have a Google graph of Google with the actual price, actual closing prices in blue, and predicted closing prices in red. So as you can see here, the predicted prices are pretty much the same as the actual prices. So yeah. Now the performance metrics, we define two metrics: mean absolute percentage error, MAPE, and normalized mean square error, and RMSE. So I compared HMM with the time series prediction algorithm EMA. As shown in the table, HMM outperforms the EMA. And what is here is that in spite of the large amount of training data set than Facebook, LinkedIn is harder to predict than others because of unforeseen patterns like this. Here we have the LinkedIn graph, which shows lots of fluctuation. So this makes the prediction hard. So in conclusion, stock price prediction is challenging because it's randomness. But HMM can be used for stock prediction by finding hidden patterns. But we didn't take into account of high, low, or volume information, which may improve the prediction accuracy. And also, in practice, we may want to know return profits rather than make. And so and also there might be a correlation between symbols. So these are the things that I like to add in the future. So this is the end of my presentation, and thank you very much.